Hello. Today we're going to start the chapter 3, which is determinant. And in this chapter, we are only going to do 3.4, which is summary of determinant. So we just need to know how to calculate determinant for a given matrix. So the matrix may be 3 by 3, 5 by 5, maybe larger ones. So this is more general. Now let's take a look at 3.4. Actually, you have already learned some of determinant in calculus 3. Do you still remember when you learn how to find the cross product, like A cross B? So you did determinant like I, J, K, then you put A1, A2, A3, B1, B2, B3. So this is determinant. So this is actually determinant for 3 by 3 matrix. Okay, so in this section, we're going to do more general. And at the end, we will also learn the application of determinants. While we learn this, and we can use determinant to solve a linear system. We can find the solution. So now let's take a look at the definition. Definition 1. Okay, the determinant of an n by n matrix. Determinant of matrix A, okay, denoted by DETA. Let's take a look at notation. DET, okay, and parenthesis A. This means determinant. What's the determinant? Is a scalar. Can be obtained in the following manners. Okay, the first case, let's take a look at the first case. If the matrix A just has one number, like A11 just has one number, then the determinant of this matrix A is just equals that number, the only one element, okay, only one element. So now let's see. This doesn't happen too much, okay, because usually our matrix is 2 by 2 above. If the matrix A is like this one, A11, A12, A21, A22, which is 2 by 2, right? So in this case, determinant equals what? DETA. And sometimes for determinant, we also do like straight line, two straight line. This is another notation. Some books also use this way, okay? You can see it's different from matrix. Matrix use bracket, right? Here we do the straight line. That means determinant. And in this case, that's equals A11 times A12 minus A21 times A12. So let me write down this one. So in this case, that equals A11 times A22 minus A21 times A12. Okay. For example, if we have like 1, 2, 3, 4, 2 by 2 matrix, and what's the determinant? If I write down this way, that means determinant, right? So it's going to be 1 times 4 minus 2 times 3, which is 4 minus 6, which is negative 2. This is 2 by 2. Next, we can try 3 by 3. If the matrix A equals this one, 3 by 3, A12, A13, A21, A22, A23, 32, A33. In this case, what is the determinant? So this is same as before when you learned in calculus 3. It's going to be, we use the first row to expand the whole thing. So it's going to be A11 times, after A11, after we delete the first row, first column, what left? Look at mine. is going to be times determinant of the 2 by 2, A22, A23, A32, A33. Okay, and the second term, which should be minus A12. Be careful, and I will tell you the reason why it's minus. And for the next one, we delete the second row, second column is kind of like this way. Look at my pen. Okay, this is the number A12 and times cross that row, that column, and what left. So it's going to be A21, A23, A31, A33, and the last number is A13 times. Okay, take off the row and the column with A13, what left? So it's going to be A21, A22, A31, A32, something like this, right? Okay, this is definition for 3 by 3. Later I'm going to give you a lot of example and exercise, don't worry. And here just definition is same as calculus 3. Okay, now let me delete those. In general case, for n greater than 3, determinant A, okay, can be computed in this way. We can do two ways, okay, either of the following formulas. So, for example, when we have 4 by 4, 5 by 5 by 5, how to calculate determinant. So that is more general. I'm going to write down A as like A11, A12, in general A1n, and let's write down the second row, A2n, A2n, and the last row, AN1, AN2, and ANN. So this is general n by n matrix. Okay, so how to calculate the determinant of this one is given by those two formulas. Let's take a look. Determinant of A equals to, okay, the formula is this one. I'm going to show you. That means if we can expand by using the ith row. For example, the ith row going to be AI1, AIN, AI2, the second number, right? So the ith row, AI2. Yeah, this number is A22. I made a mistake here. Okay, so we can use the ith row to expand. Let's see, it's going to be something like this. So it's going to be AI1, use the first number, times CI1. I'm going to show you what's the meaning of CI1 later, okay? Don't worry too much. Plus, and use the second number in the ith row, AI2 times CI2, general, and AIN, CIN. So in this case, we say we can expand the determinant by using the ith row, use the row way, okay? Using the row. The other formula, we can also expand the determinant of matrix by a column. So for example, we can use the any column, jth column. So jth column, if we say this is jth column, so it should be A1j. Is that right? The first row, jth column, A2j, ANJ. So we can also use the jth row to expand. So it's going to be A1j, C1j, A2j, C2j. Don't worry too much. The formula looks, complicated, but I will show you an example. It's pretty easy, okay? C and J. So in this case, you just need to know we expanded this case by column, by using the column. If you look at my circled row and column. And I will tell you what the CI1 means. Okay, so here Cij means what? Cij equals -1 to the I plus j times mij. This is called cofactor. This is called cofactor. Cij, so we choose C as the first letter, and the Cij has -1 times I plus j, so it has some sign in front, and times mij. And the mij means the determinant of the matrix obtained by deleting the ith row and the column. So that means determinant of the matrix obtained by deleting the ith row and jth column. It's called minus. Okay, so use capital M at beginning. So I will show you what's the meaning of that one. Okay, here I give you like a 3 by 3 matrix. 4, 5, 6, 7, 8, 9. Okay, for example, 3 by 3. Let's take a look at how to find the C22. C22 means the cofactor, right? 2, 2, and the ij means 2, 2. Let's take a look at the definition. It's going to be -1 to the power I plus j, so 2 plus 2, and times mij. Mij means determinant when we cross second row, second column, what left? Let's see. 1, 3, 7, 9. It's a determinant when we deleting the ith row, jth column. So here 2, 2. Right? I and j both are 2, 2. And calculate this one. So -1 to the fourth power times determinant. So it should be 9 minus 21. And this is positive 1. And this is -12. So the final answer is -12. That's C22. How we calculate C22? Let's think about when we calculate the cross product ijk. When we calculate, for example, 1, 2, 3, 4, 5, 6. So we use k times what? We use k, so we have I times something and minus j times something and plus k times this thing, right? So it's like 1, 2, 4, 5. Actually, this is the minus. Okay, it's also include a cofactor because it's -1 to the power like 1 plus 3. So that's why in this position it's negative. Because if we look at the j position, it's going to be -1 times 1 plus 2. So first row, second column, 1 plus 2. That's why we have minus j. So 1, 3, 4, 6. When we calculate cross product, u cross v. Right? Same thing like that. Let's take a look at this matrix. 0, 1, 2, 4, 5, 6, -1, 3, 4. Can you find C32? Let's practice this. C32, firstly, definition, -3 plus 2, and times determinant C32. Let's find C32. Third row, second column, so should be this number, right? Third row, second column. And what left? 0, 2, 4, 6. Calculate. So it should be negative. Here should be 0 minus 8. This is C32. So do you know what's the meaning of minors and cofactor? So difference between cofactor and minors mean it's just the sign in front. Okay, cofactor has sign positive or negative, and ij just means the determinant. When we delete the ith row, just column. Now I'm going to show you this one. So let's take a look at the determinant of this matrix. A22, A22, A23, A31, A32, A33, right? Let's calculate the determinant. So we can use the first row to expand. For example, the first row means A11 times the cofactor. So the cofactor is 91 to the 1 plus 1 power, and times minor, which means delete the first row, first column, A22, A23, A32, A33. Right? And the second number is going to be plus A12 and times cofactor. What's cofactor? Negative 1 to the power 1 plus 2. And the minors, which is cross the first row, second column. So it should be A22, A23, A31, A33. And the last number is going to be A13 times negative 1 to the power 1 plus 3, and cross that row, first row, third column, 2, 2, A21, A22, A31, A32, something like that. Okay, so this is same as our like before, right? Cross product. So here this give us negative 1. But you can also use, the second or third row, same thing. Let's take a look at example. We can do this from the example. That's a little bit better. Now let's take a look at this example. We want to evaluate this determinant. Okay, so because I write the straight line, that doesn't mean the matrix. It means determinant of the matrix. When we evaluate this one, we can use the first row to expand. Okay, first row. So that means 2 times, or you can just use the definition. Okay, 2 times what left should be this matrix. Right, determinant. So 4, 2, 5, 8. And the second number should be minus. And the second number is negative 1. Negative 1 times what left? Negative 1. Okay, so it should be 3, 2, 7, 8 left. And then plus 1 times this number is 4. 1 times 3, 4, 7, 5. Exactly the same as the cross product you did before. So here just do the calculation. 2 times 32 minus 10. And here plus, negative is positive. 24 minus 14, right? And the plus 15 minus 28. Let's just simplify this number. 2 times 20, which is 40, and plus 10, and then minus 13. Yes. 15 minus 13. 15 minus 13 should be 37. 2 times, so here should be 44. I made a small mistake here. There should be 2 times 22, 44. So the final answer should be 41. 54. And this number is 41. Okay, pretty easy, right? I'm going to give you one exercise and you can try. let's do this problem. 1, 2, 3, 0, 2, 0, 2, 1, negative 1. Okay. Let's see. You can try this by yourself, but I can give you a hint. We can use the second row to expand. You can use the first row, same as our example, or cross product. Okay, but second row is a little bit easier. I'm going to give you the solution here. I'm going to use the second row to expand. It's going to be 0 times anything, so we don't need to, it's like 0 times, it's going to be 0 anyway, right? So it's going to be 0 times, I don't need to write down those, okay? And the last number is also 0 times anything, it's going to be 0, but I only need to be careful here. The second number is 2, and this projection is 2, 2, 2 added 2, cofactor, and minus, which is cross that row as column, 1, 3, 2, negative 1. So you can see the number is 2 times, this is positive 1, negative 1 minus 6, negative 7. So this is negative 14. And then we can double check this problem by using the first row. You can, if you like to use the first row, that's also okay. We can double check. This is like a method 1. Let's see method 2. Like when we use the original method, this one use the first row, first column. So it's going to be 2, 0, 1, negative 1 minus 2 times 0, 0, 2, negative 1 plus 3 times 0, 2, 2, 1. So negative 2, and here 0, 0, and minus plus 3 times negative 4. Same thing, negative 14. Okay, it's not too difficult, but the first method is much easier because we use the row has more zeros. Now let's take a look at the properties of determinant. See, properties. Determinant. So let's see. The first one, if we get a matrix by using, if we permute 2 rows, let's see, if the matrix B is obtained by permuting, it's like a row operation before, right? Permuting 2 rows, same to the column. If we change the order of 2 columns of matrix A, then the determinant of B is negative determinant of A. So that means when we permute 2 rows or 2 columns, we need to change the sign of the determinant. For example, it's like 1, 2, 3, 4, determinant equals what? It's going to be 4 minus 6, which is negative 2, right? But if we do permute row 1, row 2, so it's like 3, 4, 1, 2. Let's take a look. What is this determinant? 6 minus 4, which is positive 2. You can see just opposite to each other, right? When we permute 2 rows or 2 columns, determinant is negative. Second, if this is like a Pij, permute 2 rows, let's take a look at the other, like a row operation, like a multiple ith row by number k, right? If we multiple a row by a scalar, what's the determinant is going to be? If B is obtained by multiplying any row or column, same thing to the column, of A by a scalar. K. Then determinant of B equals what? K times determinant of A. I can give you one example. It's like 1, 1, okay, how about 1, 2, 0, 4? Let's take a look at this determinant, which is like, it's just 4, right? It's going to be 4. But if we times like the first row by number 3, so 3, 6, and still same thing, 0, 4. So this is like a scalar 3 times the row 1. Let's take a look at this is 12. So this is like a 4 times 3, right? Same thing. When we multiply a row by a scalar, then the determinant of the new matrix is K times the determinant of A. Okay. Let's see the third property, and we use this pretty often. Do you still remember what's the meaning of this one? Row operation, elementary row operation. We multiply row I by a number K and add to row J, right? So in this case, the determinants of those two matrices are the same thing. Let's see. If B is obtained by a multiple of any row or column of A to another row or column, of A, then in this case, determinant of A and determinant B are the same thing. Okay, and we use this pretty often. In the future, when we have a larger matrix, we use this row operation to change the determinant, and because they are the same thing, so we still get the same determinant. I will show you later in the example. Number 4, transpose determinant is same as A. Okay. And 5, if A has a 0 row or column, can you think what is determinant of A? Think about determinant calculation. We can use any row or any column to expand the calculation. So it's going to be 0 times the cofactor plus 0 cofactor plus 0 times cofactor, because we have 0 row, right? So every number in front should be 0. So at the end, if we it's going to be 0. So if there is 0 row or column, the determinant is 0. Number 6, if any two rows are the same, determinant is 0. Why? So you can see it's like 1, for example, 1, 2, 1, 2. Any two rows are the same thing. Actually, this is same as if we do row operation like property number 3, 1, 2, 0, 0, 0, 0. We can use the row 1 times negative 1 times to add to row 2, right? So we can get this, and then we have a 0 row. In this case, it's 0. You even don't need to do any calculation. Wherever you see two same row, just make them into 0. And number 7, determinant A times B equals determinant A times determinant of B. Now let's take a look at the second example. We are going to find the determinant of a 4x4 matrix. So let's take a look at this example. This is a 4x4 matrix. We can expand this by using any row or any column, but after expand directly from here, for example, if we choose first row, after we expand, use the first row, we use number 2 times a 3x3 determinant, and then minus 1 times 3x3 determinant. So we still have a lot of calculation. So here we want to use like this row operation because we know under this row operation the determinants are the same thing. So we are going to use this row operation to simplify this determinant, and we try to get more zeros. For example, in the first column we have -1 here, and the -1 can easily make other numbers into 0 by using the row operation. Right, so let's see. Under the elementary row operation, we can make this into, and under that row operation, the determinants are the same thing. Let's see, second row, keep the same thing. And the first row, how to make that number 2 into 0? We use this -1 times +2 and add it to the row 1, can make that into 0, right? 1 times +2, so add the 1, 3. -2 times 2, -4, add there -1. -2, 2 times 2, 6. Okay, 4 add 2, 6. Same thing, -1 times 5, add there should be 0. Times 5, 5 and 6, 5, -10 and -12. And here should be 5, 11, is that correct? And here should be -1 times -2, change into +2 and add to -2, make that into 0. So times -2, -2, so +2, 5, -2, -4, add there -3. Right, so in the first column, you can see we get a lot of zeros except the second number. So we are going to use this column to expand. Okay, so it's going to be like 0 times cofactor and plus, so 0 times anything going to be 0, so I'm not going to write down this one, but it means 0 times like a C11, okay, and plus -1. -1 is the number, second number here, like a A21. And be careful, we need to times cofactor. Cofactor has the sign -1 to I plus j power. So for the I plus j, for this case, let's see, for the -1, what's the position of this? It should be 2, 1, right? Row 2, column 1, so it should be 2 plus 1. And then times the minus, which is the left matrix determinant after we delete the second row, first column. So it's, yeah, kind of messy here, but if you look at it, I'm going to delete this row. Okay, let's write down what's left. 3, -1, 6, 6, -12, 11, 1, 5, -3, and plus 0 plus 0. Right, they are all zeros, so we don't need the calculation. And here this number is -1. And -1 times -1 should be +1. So you can see, actually, we just need to calculate the 3 by 3 determinant. And the same thing for the 3 by 3, we don't want to do from here. We also want to simplify. I'm going to use this one to make those numbers into 0. Equals 2. So 1, 5, -3. And make that in 0, 0. So it should be times -3 right there, so 0, -3, -16, -3, so it should be +9, 9 and 6, 25. And here 1, 0, 5 times -6, -30, -42 here, and times -6, +18, 18 plus that 29, and we can use same thing, use this column to expand. So here should be 1 times -1 to the power cofactor, so 3 add 1, and times what left should be this one left. negative 16, 25, negative 42, 29. So here just need a little bit calculation, but not too much. Final answer is 166. So you can see this example. In this example, we use the row operation, the third row operation here to simplify our determinant. And then we expand the matrix by using the column has more zeros and make this easy, right? Otherwise, we have to calculate for 3 by 3 determinant. That's too much. And here I have exercise problem, and you can try. We want to find the determinant of this one. 2, 1, 5, 2. Because we can use any row or any column, so you can pick which column. You don't have to pick the first column always. You can pick other column. For example, you can use this one to make them into zeros, right? Or you can also use the second column if you like. You can use this to make other numbers into zeros. Either way, same thing. But the first column, because easy to calculate I plus j, so you can try this. You can try this way. And then I'm going to give you the solution later. Here's the solution. I use the 1 in the last row to make other numbers into 0. So let's see. I make them into like this. And then I'm going to use the first column to expand the determinant. So it's going to be like 0 times cofactor plus 0 times cofactor plus 0. And it's going to be 1 times cofactor. And the cofactor, this projection is 4 plus 1. That's I plus j. And then times the 3 by 3 determinant. Let's see. 3, 1, 0 here. 5, negative 1, 4, right? And the next, I'm going to just look at this 3 by 3 determinant. I noticed that the last column is pretty easy. Okay, this column is a little bit easy, so I'm going to use this number, but it's still not easy enough. I want to use this one to make that 4 into 0. So I just want to create as the zeros as small as possible. And this number is negative 1. So negative. The second row doesn't change because it already has 0 there. So row 1 times 4 added row 3. Here it should be this will be 0. Negative times 4, so negative 20. Okay, times 4. 8 times 20 times 4. 37, and this times 4, negative 28, negative 29. Okay, and let's see, I'm going to use this column to expand. So it's negative times negative 1, and the cofactor negative 1 times negative 1 to the power 1 plus 3, and times the number like this one, 3, 1, 37, negative 29, and this negative, this positive, negative, negative, positive. So it's going to be just positive of this 2 by 2 determinant. So it's going to be 2 by 2. You can see pretty easy, right? So it's 3 times negative 29 minus 37. The final answer is negative 128. 24. That's the final answer. So try to simplify the determinant as small as possible and then expand. I noticed some student like just find the determinant from the original. It will takes a lot of time and it's impossible most of the time for you to get the right answer. So turn them into simplify into 2 by 2. Okay, we can stop this section. No, not this section, this class. In this class, we just need to know how to calculate the determinant of a given matrix, including higher dimension. like a 4x4 or 5x5. And in the next class, we are going to study the application of determinant, why we learn determinant. So we can do that in the next one.